How many people here have heard of AST, the module, or used it? We have a couple of hands, one up. What about DIS? It's another couple. Very good. These are kind of like niche modules. You don't use them too often, but they come in handy when you need them. How many people here have used YouTube DL? That's shocking to me. We have more people that have used AST than YouTube DL. If you haven't used YouTube DL, definitely check it out. It is really the coolest. I think it's the coolest piece of software ever made with Python. What YouTube DL does is you give it a link, and it could be YouTube. It could be any site that has any type of media file. If it's a video, even if it's audio, SoundCloud works. If you drop it, I think even an Imgur album, it'll just like sequence download the pictures. It handles pretty much all of that multimedia stuff, and it pulls it down locally. So if you don't have YouTube Red and you want to download a bunch of stuff, put it on your cell phone and watch it in the car, you can do that. You won't have advertisements. It is really cool. For me, I'm not a Python user, and I wanted to expand upon it. So I was looking to actually port the whole project over to JavaScript and Node. There's a lot of advantages that I can see in doing that, but it's unfortunately a gigantic project. I was going to show you how much of a monstrous project it is by going through some of it. We're going to skip that. You're going to have to take my word for it. In order to move a Python project like that into Node, there's different, I guess you would say, levels of ease for that transition. The first would be we don't do any work. I just simply write something that does all the work for me, and magically the Python code becomes JavaScript code. We can run it in Node. That is sky in the, it's pie in the sky, ridiculous. There's other levels like porting the test suite, which would be really nice. Then I don't have to rewrite all of that. There's other levels that would simply port coverage, so I could see whether or not I have implemented all of those features. To do all of that stuff, I have to look at that Python code. In order to do that, I looked at the bytecode, and I looked at the abstract syntax tree, and I found some cool utilities out there that would help me in that process. So really quick, when you take a program, and it's all source code, and you want to actually turn that into something that your CPU can run, there's a lot of processes that go into it. The first is usually with Yak or Bison. Those are C programs. You're going to take that source code and tokenize it. You're going to break every little parentheses apart, all of those contexts apart. All of those become different tokens inside of that program. The next thing that happens is they all become a tree, a syntax tree, where you have operators, and then you may have both operands on each side of that tree. And you're going to look at that like this, and conditionals, all of that, get put into some form of a tree. And when you have that, that's the AST construction phase. The next thing is the transformation. And essentially, that could be any type of optimization, any type of rewriting. All of that happens in that phase. Then we generate bytecode. We usually run that on a virtual machine. And then the virtual machine generates machine code, which your CPU understands. So this is really trying to just give you a little bit of background. DIS is going to take that. This is actually mistitled. But DIS is going, no. This is actually, this is not the right slide here. OK, I see what I'm doing here. This is, I'm sorry for that. This is wrong. This is an abstract syntax tree. The title is right. This just shouldn't be there. So when you take the source code here, just pretend like this wasn't here. You have a equals 5, and then we have a simple function here. And all that simple function is doing is saying print foo. We can generate with that this abstract syntax tree. You'll notice this looks pretty poorly. This is the way Python does it by default if you use the AST module and you call AST dump or whatever. There's another utility out there called AST pretty. It does something a lot better. And it's going to generate something like this. This is a lot easier for you to consume and break down. You can see here that you have a module and you have a body, and we have some assignment thing that's going on. Moving over, we have a function definition. That's kind of what the abstract syntax tree looks like if you want to work with it. Disassembly is that it's done with DIS. This is actually taking the machine code, which is one step further. And you can see here I am just written some bad code. But anyway, we're generating essentially, this is what the bytecode looks like. So the bytecode is what is actually run on the Python virtual machine. And transcript is a really cool utility. And like I said, because I'm on this laptop, I don't have the ability to show it to you right here. But transcript actually takes that Python AST, and it gives you the ability to rewrite that Python AST into pure Node. So that pie in the sky, high, really difficult objective of making it towards seamless through and through, moving a project from Python to JavaScript, is somewhat possible with transcript. There's some real limitations to this, but you can take transcript and you can feed it a Python script, right? It generates an AST from it, And then there's like a 3,500 line compiler that transcript has that will dynamically rewrite Python code into Node code. And it does it with surprising accuracy. Turns out this project I was unable to get this to work with. And I'm actually looking at patching transcript to make it work. There are internals inside of CPython, which are part of like the container package. And those C internals don't yet work with transcript. And that's because these guys are arguing a lot about this. But this is going to be a really cool asset in the future. And I highly suggest people take a look into it if you're interested. The AST transformations and rewriting code dynamically into other languages is really cool. And it is eerily close to working. That simple, taking a counter and printing it out into JavaScript, into Python, that was able to run with transcript just fine. And they have some really complex examples there. If you want to write a web app and you don't know JavaScript, you can actually use Python to write that web app, compile it into JavaScript with transcript, and it'll run seamlessly in the browser or in Node, depending on what environment you give it. So like, if you've never heard of that project, I'm just saying that's something really, really cool to check out. And that's kind of what I wanted to bring. I don't know if anyone has any questions on it. I just kind of got this together pretty quick. Yeah.
So what benefits would you see of porting a YouTube DL from Python to Node?
Yeah, you're in the browser, and you see a video file, and you could just simply say save locally, or you could actually build the extractor right then and there. The Python extractors are an abomination, in my opinion. When you want to write an extractor for a website, you typically use something like jQuery. You have CSS selectors. The Python extractors for YouTube DL do everything wrong. They're literally just a collection of Rxjs. And all of the ability to like create the lists that you would normally see are essentially people just regex parsing and creating like ad hoc lists. There's no like generic list item. And then it just goes downhill from there. But the advantage to it is that there's like, I think there's like 2,000 or something like that extractors on there. I was going to show just the Z's is part of the demonstration, and there's like 15 of them, and I didn't even know that there were 15 sites that had Z.
That all doesn't affect like what YouTube DL does, right? Because I mean, I use it and it works like just fine. So I guess the reason for that would be so you can make like a browser plugin, so you can download stuff from the browser.
Both so you could download stuff from the browser, so you could easily create things that were more sophisticated than what YouTube DL is currently doing. It doesn't have any ability to parallelize downloads. You can do that very easily with JavaScript and using something like Rxjs, which is the reactive extensions for it. You can retry in the event you fail. So if you try to hit a web server, and then that web server isn't online or isn't communicating or provides you a bad ID, you can come back and say .retry, and it'll retry it 2 or 3 or 4 times. You have a lot of different options with the reactive extensions on JavaScript that Python doesn't yet have. So there's a lot of features there to be had. And then there's a lot of features with creating your own extractors. You use it a lot. Have you ever created an extractor? So that's one of the problems. There's a lot of extractors on YouTube DL because people do it compulsively, but there's not really a lot of people doing it compared to the amount of people using it, right? And I hope that when we reduce that to simply jQuery, it becomes more prevalent.
Extractors, you mean like plugins, right? Like something to plug in. So like if you wanted to download something from Hulu, you create like a Hulu plugin for YouTube DL.
Exactly, yeah. Or you come across a site, right? And that website, something, they provide to you a gallery, and you want to create something to download all of the things in that gallery. It should be much more easy to create something that downloads those and to contribute it back to that code base. And I think that would be a lot more possible if you followed something like a jQuery or CSS type of notation for creating that plugin. But there's some other things, too, that I think are really funky about YouTube DL. I didn't really want to get into that because it's not really, I wanted to show more of like the AST and the disassembly stuff and how I'm using that here. But yes, there's definitely a lot more features we could do with like Rxjs and JavaScript. Yes?
So how do you think you would tackle debugging?
That is a nightmare, right? So if you've ever done transpiling, that's like the 600-pound gorilla as far as the problems go. What do you do when there's a problem? If you can write transcript and you can read that code, the compiler, it's not really all that bad to debug that code. For the average person, it's going to be simply hellish. Now, they do output source maps, and like source maps are great so long as the compiler is doing what it's supposed to be doing right, but they do fail. And if you've ever used TypeScript, as far as JavaScript is concerned, you can still have those same types of problems, right? So TypeScript is monstrously popular in the JavaScript community. It allows you to write typed JavaScript, and it has the same issue. At the end of the day, what's run is untyped JavaScript, ES5 or ES6, and you have those same problems with debugging. You know, but nonetheless, everyone's using it, so you know you can get around them. All right. Yes.
So I don't have any experience with flopping between Python and JavaScript, but if something is Turing complete, it's got to be easy to like convert over. Is this like the normal standard flow of flopping it over to AST before?
Not every language produces an AST. Like Python is not nearly my favorite language. Sorry to blow everyone's. I think it's got a lot of cool stuff. Maybe I'm in the wrong room to say that, but I will say this. I will say this. The AST stuff that Python does is awesome. I like Perl better than Python. Perl doesn't have an AST, right? So you can in fact fudge your compiler chain so bad that you can't actually produce an AST, and then you literally just say the only standard for the language is the thing that runs it. And you know, thankfully, Python didn't go down that route. To Python's own merit, this is the right way to do it. The AST bytecode, and then you can, you know, you even look at the disassembled bytecode. All of that is there.
Follow-up question. What
Yes.
are the flags and what's the output of that?
Okay. Oh, geez. Okay. E6 is simple. That's ECMAScript 6. N, I don't know. P none is the base object. So .none is like a special thing. That's like a makefile phony thing, I think is what they're trying to go for there. If you ever wrote, you know, GNU makefiles. B is build and recurse down. I don't, dot N, dash N. Someone's got to look that one up. But yes, anyway, pretty good accuracy. I was pretty impressed with the tool. To give you an idea of some of the difficulties, there in Python you have this thing dictionary, and everyone uses it, and it's really hard to reason about what that is when you go from Python to another language. If I ask you what is a dictionary in JavaScript if you use Python, who here uses both?
It's an object.
Okay. Okay, everyone says it's an object. It's wrong, right? So there's a lot of things that you can do in JavaScript, in Python, in the notion of a dictionary that you can't do in JavaScript. Python dictionaries are ordered insertions. That's new with 3.6. Just FYI, 3.6, it's now part of the language specification. So if you insert crap into that, you have to be able to iterate over it and get the crap out in the same order. JavaScript makes no such thing about its traditional object thing. So there's also a map in JavaScript. All of this crap has got different, like, you know, give and takes. And the transcript guys have been literally arguing for 18 months about which one of those implementations best matches Python, which is a really, really cute ticket. Yes. Anyone else have questions about the phases or one more? Yes.
So you clearly like JavaScript, the language.
Yes.
Do you like the unminified output of transcript?
Do I like the unminified output of transcript?
It does have an unminified output.
It does, yes. And like, here's the deal. The deal is I don't write JavaScript in such a fashion where or Python for that matter. How many people here actually rely on ordered insertions in their Python dictionaries? No hands have went up, right? So it's when I understand their difficulties. Their difficulty is wanting to support Python. The reality is that you can't generate pretty code when you want to support a language that has that kind of stuff in it. And it's not Python's detriment. You know, it just is the way it is. But yeah, it makes it difficult to generate what I would consider idiomatic, beautiful JavaScript. Yes?
Python is no minification.
Beautiful. There we go. So that's how you generate the no minified. By the way, I can read it. It's not so bad you can't read it. It's just not pleasurable. But yeah, this is definitely going to be a huge tool if you're looking to move to Node. And there's a lot of really cool stuff if you go that direction. Anyone else? Any questions? OK, very cool. If you have any other questions about this, Houston Linux Users Group, we go over compilation and all of that kind of fun stuff quite frequently. And these are fun tools. Cool. All right.